All right, I guess we are live. Welcome everybody for this next data-minded webinar. I hope you can hear me all right. I hope I don't speak too loud this time. So for those of you in the chat, can you just post if you can hear me all right, if everything sound and video is good, and then we can get started. Yeah, it's all good. All right. I have with me Oliver. He's one of our senior data engineers and also the head of the Data-Minded Academy. And my name is Chris. I'm the founder and CEO of Data-Minded. And today, the topic of today is the 6 skills that we think every data engineer needs to be successful in his job. For those of you who don't know Data-Minded, we've been doing data engineering for the past 7 years. We've learned from our own mistakes. We've seen what works at clients and what doesn't work. And we kind of synthesized that into the 6 basic skills that we'd like to present today. But before we dive into the skills, for those of you who joined webinars before, we always ask questions to the audience first, right? So we're going to start with a questionnaire. I'll post a link in the Slack in the chat, and you can follow the link there, and we're going to ask you a few questions. So here it goes. Yeah, and I'll share my screen in the meantime because I'm going to show you the answers while you're filling in the questionnaire. All right. So the first questions that we're going to ask is rate the following statements in your organization just to get a feel of how far you're already at with data engineering. So do you apply data engineering in your day-to-day work? Is that a skill that is relevant at all? I hope, or I guess it is, otherwise you wouldn't join this webinar. Do you have enough skilled data engineers to serve your business needs? We kind of expected there to be the answer slightly on the left because we all know there is a shortage of data engineers, right? So it's nothing new. And then, are you actively investing in building data engineering skills? Then we kind of hope to see that shifting more to the right, obviously, because if we all realize that we need it and we don't have enough of it, then are you building the skills in your organization? And then the fourth one is a bit more advanced question, but we're curious to know, like, do you have a cross-functional team? Do you have all the skills in-house that you can deliver a data project end-to-end? So with that, we mean infrastructure, data pipelines, machine learning models, data warehousing, tables, models, what have you, dashboards, so everything end-to-end. Do you have that? And there's 11 people answered already, and we see a trend. Like, are you applying data engineering? It's kind of in the middle. Yes, but not fully agree. So it's curious. You don't have enough skilled data engineers to serve your business needs. Well, one of you does, right? So for that person, well, congratulations. I mean,
you're amongst the lucky few, apparently.
Yeah. Most of us are always understaffed and have too many tickets in our backlogs, but it's good for you. Are you building engineering skills, data engineering skills? I'm a bit disappointed with this because it means that although, and it's probably not your own personal in control of that, but it's kind of a bummer that companies do realize that, hey, we don't have enough data engineers, but we're also not investing enough in data engineering skills. So yeah, the solution is obvious, right? And do you have a cross-functional team? Yeah, that's still early days. Okay, that's fair enough. So let's skip to the next question. We obviously going to tell you what we think are the 6 skills because that's the entire topic of the webinar, but we're also curious to find out how you see the skills of a data engineer. So if you work on data engineering projects or you work with data engineers, what do you see them doing day to day? What is important for them? So already first answer coming in, so SQL, Python, data pipeline, scheduling. So yeah, that makes a whole lot of sense, right? Let's wait for a few more answers to come in. Business understanding, yes, definitely. Containerization, that's already quite advanced, but indeed containers is a big aspect of modern day data products and data platforms. So if they know about containerization, it's a big plus. Databases, cloud platform, basic development skills. Yeah. Custom data extractors. Yeah. We as a data engineer actually spend quite a lot of time on doing ingestion, right?
Yeah.
It's always one of the hard parts. Data test, lineage documentation. Yeah. Okay. There's a lot of things coming back. And we see some common patterns like Python, SQL, data pipelines, databases. Definitely yes, all of that. maybe the odd one out here is business understanding. Of course, you need to know what you're building and who you're building it for, right? So you can be the best data engineer in the world. If you don't understand what your business needs, you will never succeed. For the context of this webinar, we're going to focus on the technical skills, right? Yeah. All right. Then maybe that brings us to our next question, and then we're going to go to the content, right? So don't worry, it's not 1 hour of survey. We've listed the 6 skills already here, so spoiler, these are the 6 skills that we think you need to have as a data engineer. Would you be able to rank them in terms of importance for your organization? Like if you had to choose only one skill, which one would you have to put on top? And then which ones would you put on the bottom that are less relevant for your organization? We're curious to find out here. And I told Oliver when we made this survey, if there's one particular item that ends up at the bottom, I'm going to be sad. So but let's see which one ends up at the bottom. I'll give you some time to rank them. If all is well, you should be able to sort them in terms of priority.
Of course, now the people who know you, they're probably going to say like, oh, that's probably the one he doesn't want to see at the bottom, so let's put it at the bottom.
Yeah, indeed. So please don't skew my results. Well, with like 10 answers, you can't be statistically correct anyway. But yeah. Okay, there's a few answers coming in. Deployments, triggering software relational databases is on the top. General purpose programming languages. PySpark is at the bottom. Okay. Yeah, so actually they're all quite close to each other. But PySpark is definitely, you see, significantly down on the hierarchy, and infrastructure as code actually, yeah.
I'm a bit surprised with PySpark at the bottom, but maybe it's because you wrote PySpark, not Apache Spark. So for people who are thinking like, yeah, it's Python, and maybe I want to talk a bit more about a strongly typed language, and then consider the other flavors of Spark as well.
Just Scala Spark.
Yeah, Scala Spark, for example.
Well, I don't know. Maybe it's because there's a lot of debates at companies like, should we do Spark, yes or no? Because Spark brings all this big data capabilities and processing, but also brings a lot of complexity. So if you can do it with a relational database or with Python, then why would you introduce Spark? And so it's a valid point. But so I think the clear winner is you should know how to code. Fully agree, by the way. And then there's like 4 contenders in the middle, more or less. And then the final one is PySpark at the bottom. The one I cared about most was relational databases, by the way. I think it's a cornerstone of data engineering. So if you don't know how databases work, I should, in my opinion, should be a number 1 skill to work on. Okay. With that being said, let's dive into the content. Thanks for your feedback so far. I'm going to switch screens here if I can do that. No, that's a terminal. Here is my screen. Oliver, I'm going to leave the floor to you. Yeah, Oliver decided not to use Google Slides like everybody in Data Minded, but he has his own, obviously, has his own slides tooling, so he can control that.
It's not that difficult in any case. All right, then let's have a bit of a look at the things that we have prepared here. So indeed, you already had a bit of a spoiler, the 6 skills that every data engineer needs. Not per se ranked in any particular order, we're just going to label them as they are. The first one would really be fluency with command line tools. Yeah. There is no going about it. I mean, you need to know stuff like Git and Bash. You need to be able to navigate your way through this, the terminal. Lots of things can already be done in your shell. Yeah. And it doesn't really matter which one you use, but you need to be able to use it proficiently. You need to navigate to the front of the line, to the back of the line, move words, remove words, and use some of those programs. Yeah. grep is a very basically it's all Linux based, but nowadays PowerShell is making some good strides there as well. So whatever you use.
No.
You want to go into the PowerShell? Well, keep in mind, indeed, most of the machines, of the virtual machines and Docker containers will always have some kind of a Linux architecture behind it. So you're basically going to be working with Bash.
Yeah, it's also a religious war, by the way. I'm not a fan of PowerShell, but if you're productive with PowerShell, by all means, right, do whatever makes you productive.
Indeed. Amongst these command line tools, one of the most important ones is Git, and that's really a way for you to professionalize. I mean, you can write code all you want, but coding is a very social business. You are going to be collaborating with people, And at some point, you're going to need to share your code, and people are going to revise your code. And if you are only going to be sending that through email, then you're going to have a very, very painful way of deploying stuff.
And this might sound obvious to a lot of you, like, of course you need to know Git. But we have some conversations with organizations say, can we abstract away all the Git complexity and all the command line complexity? I just want to point and click and write my SQL code somewhere. And again, whatever works for you is fine, but we believe that if you want to have reliable data products in production, if you want to have a bit of control over what happens, if you want to have some collaborator engineers, this is a given. This is also not super hard, right? This is just like telling a car engineer that he needs to operate a wrench or a screwdriver or something. Yeah, of course you need to know that. I mean, you can design the best engine you want. If you can't understand basic tooling, then you're always lost, I think so. Yeah.
And it's a bit unfortunate that some people believe that Git is very complex, because more than 80% of your work is done with just 6 commands. If you can know in Excel how to do some functions and navigate the menus, then you can definitely remember 6 commands.
And pro tip, never do rebase, Git rebase. It confuses the hell out of me. Yeah.
We differ in that opinion.
Yeah.
The second one is that you should be skilled with SQL. There is no denying it. SQL is here to stay. At some point, people thought that SQL was on its way out. That is not the case. It is here to stay, and it's because it's a really convenient way of thinking about your data. It's a declarative language. You basically say what you want rather than how you want it. And let's going to immediately go to the next one here. This is an example of a SQL statement, and it's already a couple of lines long, 35. Here you already have most of the basics. Again, the basics are covered with just a few commands, right? You have select from, I think it's already highlighted here.
Yeah.
That's the basics, like select from, join. These things come back all the time.
Yeah.
And that is how we describe what we would do with a bit of data as well, right? If you think about a big spreadsheet, for example, and you want to do some manipulations with that in your brain, you're saying like, yeah, I'm interested in that column and that column, so I'm going to select those columns.
Yeah. It's almost plain English, right? You say select this thing from that table. It's like you could also almost make a chatbot out of it, right?
Exactly. Yeah.
Yeah. All right.
But I also believe here that we should not keep working as it's 1992. A lot of things have happened since then. 1992 was one of the standards, but some major improvements, and these are things that you're going to see more and more even nowadays with tools like DBT. They're really making it more popular to use common table expressions. They have been around since 1999, if I'm not mistaken. And this is just one of those examples. There's always with some identifier as, and then a little subquery basically. And it makes it convenient because you can reuse these things. And it actually binds a little bit to the way that people would use more like general purpose programming languages. Each of these subfields here, like this subquery basically, can be reused multiple times in your query.
Yeah.
Which is convenient. You're not caching it per se, so there's no performance gain, but at least it makes it more reusable.
Yeah, you make it more modular, right? Yeah.
Another thing is that one of the really powerful things that came to be was the over clauses, which are like analytical functions where you can do a lot of stuff. Like I've seen it oftentimes happening. People do, first of all, they take a table, they do some group by aggregates, and then they do a self join to the original table. If you have that kind of pattern, oftentimes you can do it way more performantly if you use an over clause.
Yeah.
So this is just
or windowing functions.
Windowing functions, indeed. That's also the alternative to call it.
Yeah. All right.
So yeah, SQL is here to stay. I believe even if that is the only thing you're going to be doing, at the very least you're going to be a good analyst.
Yeah. Well, and my opinion on this, I think in general, if you start building out data platforms today, 2021. Most of your use cases probably fit SQL patterns, right? And with tools like DBT, you can structure your data pipelines using SQL. You can query your data using SQL. So if you only have one tool to choose, like learn a relational database, learn SQL, and you won't be able to solve all use cases, but you should be able to get there 70 or 80% of the way with 20% of the effort.
Yeah, exactly. The third one is that you should approach infrastructure as code. This ranked quite low. I think it was number 5 on the list.
Yeah, second to last.
Second to last.
Because it's an advanced topic as well.
It is a bit more advanced, yeah, indeed. But it definitely helps you to be more well-rounded and for you to be able to put your own stuff into production. I mean, I believe you shouldn't be reliant too much on other people to do it. It is still a social business and you're going to have people who have expertise in certain things. But as long as you can have your infrastructure as code, you get a lot of advantages. First of all, you have version control, back to the Git stuff already. It's all in one place. You can easily look at it. And this is much easier than going to a user interface, a web browser, for example, and saying, okay, I need this, click, type. This is super annoying. You don't know when somebody has made a change. You don't know what is out there right now if you're using only web user interfaces. And infrastructure as code solves that problem. You have traceability. Why did a certain change happen? And can we scale these changes? Like, very good example, if you have a virtual machine in your development environment and you need it as well in the production and it needs to be quasi the same, that is very easy when you have it already written as code. That's probably one change and you're done.
And maybe that's why it ranked second to last. For some people, this is a high barrier of entry. To be honest, it is intimidating, and I'm one of those guys who's also always fighting with Terraform to do this. It's not super trivial. On the other hand, we've also seen organizations, they say, no, it's too complex for us. We're just going to click everything together, all our infrastructure together in the cloud. If you then come back to that same organization a year later, they're actually nowhere. They barely got a use case live. They struggle with having a separate dev and production environment and keeping those two in sync. If you ask anybody, like, what is actually deployed where and what kind of databases do you use, nobody knows, right? So I agree it's an initial hurdle, but once you get over it, it's actually quicker. I know quite a few engineers at DataMinded who barely know how to use the web console anymore. If they can't Terraform something, I would be afraid they can't spin it up. It's like, oh, I don't know how to do this.
The fourth essential skill is a general purpose programming language. SQL is powerful, don't get me wrong, but there are certain things that are hard to express in SQL. And for that, you need something that's more general. There are lots and lots of good examples for general purpose programming languages. We've listed them here on the slide. If I would have to make a recommendation, it's going to be Python. And that is only because I see a lot of people converging on that one. It's a very low barrier kind of language, similar to SQL. It also reads like pure English. It isn't, sorry to be dissing here a bit on Java, but it's not full of factory patterns and these are good things to have. But it makes it very hard to read, whereas this kind of logic is a little bit more hidden in Python. It's more fluent English, basically.
And what would you say to those people coming from universities and academics who know tools like MATLAB?
MATLAB is not a general purpose programming language.
Okay.
It tries to be, and there are definitely, it's been already a couple of years since I've seen it, but it's missing a lot of functionality. So actually, I'm hoping that a lot of universities, and definitely here in Flanders as well, that they switch their curricula and that they start implementing Python in the bachelor's degrees already before they start introducing MATLAB. It's a very powerful thing, but lots of stuff that you could do with MATLAB, you could do with NumPy as well. So I don't see the advantage there. Try with MATLAB to make like a web request. It's just not easy.
It's horrible.
It's horrible. Yeah. It's designed for numeric computation, but not for manipulating data that is not just numbers, right? Yeah. And many of the things that you're manipulating are not always numbers. JSON files full of strings, dates, whatever.
And that's the power of Python. You can do all these numeric computations with tools like NumPy or Pandas, but you can also do many other things, right? And then, that's why, well, as you said, general purpose. You should be able to do many different things. Yeah. All right, cool.
For those who don't know, this is a simple Python program. It just scrapes web API. And the only thing I really want to highlight here is that the basics, in my opinion, that you should really know in any general purpose programming language, is you should be able to know a little bit what a for loop is. Every language has its way to iterate over a sequence or a container of data. That's typically a for loop or something like that. And a few of the basic data structures. For example, here's a literal dictionary that is starting. If you know these things, that helps a lot. In the courses that we teach, we also already gauge a little bit beforehand, do you have a clue what a variable is? If you don't have a clue what a variable is, then you're really at the start of your progress in becoming a data engineer.
Yeah, and it doesn't have to be very complex theoretical computer science or something. You don't need to know what a B tree is or very complex data structures, graph algorithms. I mean, they're all good to know, don't get me wrong, but just understanding how a dictionary works, how a for loop works, how you create a function, that honestly, like sometimes we consider ourselves as computer scientists, and many of us have backgrounds in computer science, but 99% of our work is dictionaries and for loops. Right?
Yeah, you can get a lot of things done just with those basics, and the other things you learn on the go.
Yeah, absolutely. Cool.
The fifth one, ranked lowest, is Apache Spark. Yeah, indeed. I was really surprised to see that one so low. How would I describe it? It is a way to process data at scale. And it's not just about the volume that people usually think about, but it's also the speed at which you can do it. It's one single API to process both large volumes of data, but also streaming data, which is really convenient. If you already know a little bit about how to transform data with the data frame API in batch, then a lot of those concepts immediately transfer for doing it with streaming. Yeah. And a lot of those same data structures are also coming back in the machine learning API from Spark.
Yeah.
So it's quite well rounded. It's very convenient that you have one single tool that can do these very common tasks nowadays. Yeah. Batch, streaming, machine learning, and even graph networks to solve all these things. One unified API makes it convenient.
Yeah, indeed. Well, it has its pros and cons, but definitely, if you have use cases where you see your regular Python job struggling or running out of memory or running out of time, then definitely transforming them into Spark is an obvious win, right?
Indeed, yeah.
All right.
Here too, because we're talking about PySpark, that is only because we believe that if you should learn a general programming language, Python is a good choice. Doesn't have to be, but it's that mix of Spark and the language of choice. In this case, it's an example of Python. A lot of these things that you see prefixed with PSF, which is from PySpark SQL functions, this is really the Spark specific part, but there are also parts that are pure Python and you can just combine them. This is pure Python here, that's basic nothing. Okay, yeah, there is one part here that's the summation from PySpark. But other than that, I'm using a for loop here again, just to make sure that I don't need to type out 20 lines because I have tons of bins there or something. I don't want to type that out. I want something that's convenient and easier to maintain.
What we do see sometimes is PySpark being a bit abused just as a shell to enter your SQL commands. So you can also just copy paste SQL in Spark, and it has its benefits, but sometimes you see like the actual Spark being used is like 2 lines, and then it's just please execute these 5 SQL statements. Thank you very much.
And then they are 100 lines long, and the problem there is that you can't test that, and that is something I believe that when you use really the data frame API, it makes your code more modular and therefore more testable.
Exactly. If you have that case, either you do it Spark native, you decompose your SQL statements into Spark functions and you test them, as you said, or you move the thing to DBT, right? Where you just do it in SQL. But one of the two, but don't butcher them.
Indeed.
Right.
The sixth and final one is about deploying and triggering software.
That was quite high up.
Yeah, indeed. And this is one of the more advanced topics, really. To know how, you can write, if you know all these 5 things already up till this point, you can say, I know how to transform data. That's all good and well. But if you don't know how to run that in production, where things are going to get used, then you have a problem. So you should also learn about how to deploy and trigger the software applications that you have been writing. Common tools there are that you know about Docker. It has really been one of the most transformational technologies in the last decade. Infrastructure as code comes back here as well, and continuous integration, continuous delivery, preferably as code. A lot of tools, again, allow you to just click in the browser and make your CI/CD pipelines, but I see also a good move from many of these vendors that are making it easy to configure in a YAML file, which is perfect.
Yeah, much easier to maintain again. Yeah,
indeed.
Absolutely. Yeah.
Just for those who don't know, exactly because it is more of an advanced topic. So Docker has been an evolution over virtual machines, basically. Whereas with virtual machines, you are abstracting the hardware. With a Docker container, you are abstracting the operating system. So it makes for a very small image. It makes for a much smaller environment, if you will, where you can control things.
And the nice thing is that if I have a Docker container running on my machine, I can be pretty confident, not 100% confident, but I can be pretty confident if I deploy that to a dev environment, to production environment, it will respond more or less the same, right? Whatever is in the Docker container behaves exactly the same. Of course, you run it in different environments, so your networking and stuff might be different. But for my logic, it behaves exactly the same no matter where I run it.
Yeah, indeed, and that blends very nicely into DevOps, right? I mean, there was and there probably still is the mindset of people like, hey, I've developed something, works on my machine, throw it over the fence, and can you put that in production, please? And then you get long email threads like, hey, what do we need to do? What do you need? How do I need to configure this? No. I've built that pipeline nowadays, and I can write for myself what I'm expecting. What does my environment look like?
Yeah.
On the right side of the slide, you see a Docker file, which is like a couple of lines long, right? It's nothing big, and it just tells you how much you need to run a certain application.
Yeah. All right.
Continuous integration, continuous delivery. I've taken here an example from Azure DevOps. It could have taken it from many other vendors. There are many tools that allow you to do this. But basically, it's a way for you to say, hey, I have several stages to deploy my code. For example, if you have your Java program, the first thing you're going to do is that you're going to compile it, you're going to build it, you're going to make some kind of an executable archive, the jars. And then the second step would be, okay, now once it's built, I'm going to run the sequence of tests. Is everything still working the way it should?
Yeah.
And that's the next stage. And when that is done, you can say, okay, maybe at this moment I would like to do something else. And I'm going to maybe already start pushing it into the machines where this jar will run. And that is the sequence of your continuous integration, continuous delivery pipeline.
Parts unlimited.
Yeah, it's a typical one from the Azure examples, right?
Okay, because it's also in the Phoenix project that they parts.
Yeah, indeed, true.
Anyway, for those of you who don't know it, read the book, The Phoenix Project. It's really a great book. Anyway,
many tools will allow you also then to look at recent deployments, right? So if you've done a git commit and git push, at that moment you're expecting all of that stuff to go automatically, right?
Yeah.
It should test, it should build, it should test, and it should immediately deploy to the environments where you need it. And at some moment, if something is failing, like a unit test is failing, yeah, great. Your CI/CD is your last defense. Yeah. And that is really something you should master. I love it. I believe it's the last defense. You should also get some stuff earlier. If you already have like Git hooks, which would be really nice to have, then you have it already much closer to heart and you can develop more quickly. About this last thing about triggering software, we are a big fan here at DataMind of Apache Airflow. It gives you the option, and you see it here at the top, it gives you the option to say certain things need to run at a certain
sequence.
A certain sequence and based on previous things. I cannot run, for example, my SQL aggregation if I haven't done the ingestion of the data, for example. So you see that sequence in the top chart. And here too, again, just like with CI/CD, you have a very nice schematic that shows you just over time which steps of my pipeline did not go successfully. In this case, everything is working except for the white parts, but it could be that they were added later. Yeah, it's a really convenient format. We're a big fan of it, but there are other platforms as well that allow you.
Like Prefect or Dexter. So indeed, we use Airflow the most because we see it coming back most of our clients. It's not perfect, but it does the job for us. As long as you use a tool, right? Some people either just run cron jobs or they abuse the CI/CD system to build data pipelines. And I know you can get it to work, but really there are purpose-built tools to do exactly this. They're open source, so just get started with them, right?
Finally, now that you know what our take is on the 6 basic skills that you need to become a good data engineer, we also like to provide a bit of a growth path, especially for those who are really new to everything.
It can be a bit intimidating, right? If you're new to data engineering, you're listening here, you've been thrown a lot of concepts in your face. It might indeed be a bit uncomfortable. So you indeed take it step by step, right?
Indeed. And in that sense, I believe starting out with the basics of programming, learning SQL at first, and then learning Python. SQL, if you feel at that moment that that's just the level you can handle, fine. You can still become an analyst. And by the way, analysts, you need them in every company, right? So this is super popular. It's still going to get you a job. But if you already feel like I can do more and you like the general purpose programming language with Python or something like that, then you can see, okay, maybe I can do even more.
And it's interesting that this, like learning general purpose programming languages, was also with you in the audience rated as the most important skill.
Yeah.
And this also comes back for us as, and we didn't script this or anything, right? It comes back as step 1, learn how to write code. Yeah.
Indeed. Second, professionalize your work. You can feel me coming. This is where you really need to learn stuff like how to write unit tests and how to work with Git, because you need to interact with people. We might have people who believe they can do everything, and that might happen. Yeah, sure. There are very intelligent people, but you are one person, and you cannot do everything in the time allocated to you. Yeah. So trust on your team. Next, integrating your application. So at this moment, you'll probably have already written data transformation pipelines. You're not yet fully ready to put that into production yet because you're missing some other skills. But maybe you can already make them work with other things. So in that case, learning about Apache Airflow would be a good way. That way you can say, I want to run pipeline X that I wrote, I want to run it after pipeline Y. Yeah. So it would be a good way to start integrating with the work from other people as well.
Yeah.
Next, dealing with data at scale. The one that you rank lowest, it's about learning Apache Spark. We still believe it is super strong if you are doing some kind of serious data manipulations. But I must admit, sometimes it's being abused. I mean, if you only have it, like we've had a discussion recently, like somebody had to process 20 megabytes of data and they used Apache Spark for that. That's not a good use case.
No, because by the time you've spun up Spark, you could have processed the data with Python already, right?
Yeah, exactly. Yeah. Or even with just a pure shell. We didn't demonstrate it here, but like the typical, I want to watch, look at a certain column from a spreadsheet and see how many distinct values we have, something that's perfectly done with a shell.
I won't name his name now because I'm not sure, but I had a discussion about exactly that with a previous employee of Data Minded who's now an architect somewhere. And he was super convinced, and he was not wrong, by the way, he was super convinced that at a client where we were building very complex Spark pipelines, he said, I can replace 80% of these Spark pipelines with Bash tooling. And he wasn't wrong. I wouldn't say I would go for that approach, but he wasn't wrong. So it's an interesting train of thought. Like, yeah, a lot of the data manipulation we do, you can just do straight in the shell, right?
Yeah, absolutely. Yeah. Although that would be harder to test.
Yeah, well, maybe let's invite them over for a beer and have that discussion again.
All right. Finally, you need to become self-reliant, right? So you know how to work with other people's work, integrate all of these things together. That's really the moment when you should learn about Terraform, so that's infrastructure as code, and Docker as well, so that you can that you don't need to say, hey, here's my code, throw it over the fence. No, you can do these things.
Yeah, you build it, you run it.
Indeed. Yeah. At any moment of this growth path, you could say, like, I'm going to stop here and I know enough. And that is good because you can do a lot of things. For example, if you're going to be like a machine learning engineer, then maybe you can already stop after, I would say after Git and writing tests would be nice.
Yes. But also as a machine learning engineer, Git and tests are valuable.
Yeah, indeed. But then at the very least, get to know the concepts about these other things. What is Spark? What is Airflow? What is Docker? That could be convenient as well. So at the very least that you are informed about these things.
Yeah, just like me as a data engineer, I try to know the basics of data science. I try to understand how logistic regression works, what feature modeling is. I won't be very good at building my own models, but at least I should be able to have a discussion with data scientists about this, right? And the same the other way around. The data scientist doesn't have to build his own Kubernetes platform, whatever scalable thing, but he should know the idea behind the Docker container, for instance.
Yeah. Good. Yeah. And even then, for example, also analysts, I believe Git for analysts is also something that you should master.
Yeah.
Nowadays, when we see DBT coming back a lot, that's the moment when you should say, okay, we're going to put this in version control so that everybody can optimize the queries that we have. I like that.
All right.
That's it for our growth path. I believe we would also like to announce something that we have planned here. At the end of August, August 16th, I believe.
Yeah, yes.
We are organizing our first data engineering summer school. This is one of the things that we've been working on at Data Minded. We're not just doing consultancy. And we have our own data product, which is Datafy, which allows you to basically not take care of the infrastructure. This is managed for you. And you can focus on what brings value for the company. But we also have a pillar on upskilling the clients that we work with. And also internally, we're using these things. We have courses internally that we give to our people who are joining us so that we can make them more proficient at what they're doing.
Yeah, indeed. So in the end, whether it's consulting or product academy, in Data Minded, it's all about accelerating data engineering. So making sure that our clients can get more value out of the data engineering work faster, blah, 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 all these things. And yes, I mean, definitely keep coming to us for consulting work because we love doing that, but you should also build these skills in-house. You should be able to be self-reliant as a company and only work with the experts when you need to do something complex or something new or something innovative. But for the rest, we don't see enough clients building data engineering skills in-house, actually, to be very honest. And it's very hard for clients to hire data engineers. It's very hard for us as well, right? It's very hard for everyone. So maybe you should let go of hiring the best data engineers that are available on the market, but you should focus more on who can I train to become our next data engineers. And that's where we want to help with the Data Engineering Summer School. So it's a very short and intense program. It's going to be 5 days on site where you will see most of the things that we just discussed. And besides those 5 days, you will also get the opportunity to watch the videos and prep some of these sessions. So overall, your workload, you should think about a very intense 10 days that you're going to have. You won't be a senior expert data engineer that solves all the problems, but you should know all the different aspects of data engineering at a basic level so that you can contribute in data engineering projects, and it should kickstart your your career. You should be able to contribute to projects from then on.
Exactly. If you're interested, the URL is not on the slide, but it's dataminded.academy. So dataminded, one word, academy, just like you see it on the slide.
Yeah.
And then have a look around.
All right. With that, I think we can go back to questions. So we're going to go back to Mentimeter because I have I'm going to throw it back to you to ask your opinion and also give you the opportunity to ask some questions to us. So let's see, we have to go back to, I'm always opening up my terminal, that's not helpful. So we are here, the presentation has been done. So yeah, we just did the presentation. Here are the 6 skills again: relational databases, general purpose programming languages, PySpark, infrastructure as code, deploying and triggering software, and basic tooling like Shell and Git. So if you would rank them this time on 2 axes, so what is the current knowledge in your organization of these things, and how important do you think they are? Now that you had the explanation of what is behind them, we're curious to see which toolings will end up here in the top right. That means that we know them really well, and they're also very important. So these are the core things that you're working on. And then here in the top left is also very interesting that you recognize that these are important, but there's not enough skills in your organization yet to use them, right? And also, of course, let's see what ends up at the bottom here, so that you don't really care about. Maybe PySpark will end up there again. It's going there. It's only 2 answers yet, but let's see if more answers come in.
It's very interesting.
Yeah, and it's nice. It's live updated, so you can see like what's the distribution of the answers. So yeah.
So relational databases, I'm going to guess that a lot of people have good knowledge about. I'm going to say that's my guess. Again, it's going to go to the right. And importance, yeah, it's probably going to stay though somewhere in that region. Yeah,
indeed. That's and I guess where most work is needed, because you rate it as important but don't have a lot of knowledge yet, is for infrastructure as code.
Same with Spark. Yeah. And it explains why Spark was probably ranked lowly in the beginning. I mean, onbekend maakt onbemind. If you don't know it, you're not going to love it. Infrastructure as code, I would like to see again from the previous slide how low that one scored, because again,
it was the second to last.
Second to last, again. So again, these things, because we have so little knowledge about them, it's probably the reason why we don't believe that they're perceived initially as quite important.
Yeah. So even we don't have a lot of data points, but you see, it's almost a perfect line here. So there's indeed a correlation between your current knowledge and the importance, right? Correlation is not causation, Oliver. I don't have to tell you that, but Yeah, indeed. Especially PySpark is an obvious one where there's really not a lot of knowledge around PySpark. Whether it's important or not, it's hard to decide if there's not a lot of knowledge, right? Well, if you look at the other, like there is very good programming language knowledge in-house, but you also rate it very important. The same with databases, great. Basic tooling as well, it is very important. Yeah. And then maybe here a bit more in the middle, deploying and triggering. I'm fine if there's not a lot of knowledge about this, so that's cool. It should rank at the very top of importance, for the very simple reason that I don't care what you build if you can't deploy it, business can't use it, so who cares, right? So it should raise a bit. All right, but this gives us a good view. Maybe let's open up to questions from the audience. I'm also going to, so you can post your question here in Demio. No, not in Demio, in Mentimeter, and it should pop up on the slide. I'm also going to check out if somebody left a question on the chat in Demio. So you might see us now 10 times now. All right. How would you compare PySpark to Dask? Maybe let's start with that one.
I've only had one time a bit of an encounter with Dask, and I liked very much the way they configure the clusters compared to what you need to do with PySpark. But it's been a long time. With PySpark, I really feel that the API is well thought through. I'm not going to say that with Dask you don't have that, but for somebody who knows SQL a lot, you're going to get used to the data frame API from PySpark very fast, whereas the one with Dask is going to require you to already be very familiar, for example, with the Pandas ecosystem as well, because it's more based on that one.
Yeah, maybe to add to that, we know quite a lot of organizations who work with Spark or PySpark. I know one big, and I'm not sure if I can mention them, so I won't, but I know one big organization is doing super cool stuff with Dask. So it's also in terms of just having your chances for success, right? So if you know Spark, you will end up being able to end up at a lot more organizations where you can use your skills. Well, if you know Dask, chances are slimmer. That being said, I mean, whatever makes you productive. Also, if you're in a team and you have to figure out the tooling yourself, you have to make the choice of tooling, test it out, right? Test Dask if you like it.
Yeah, indeed.
It, right?
Is PySpark interesting to use on a single machine? I would say yes, but it depends a little bit on how many cores you have, right? I still find that if I'm doing a quick analysis on my laptop, because I just need to know something to make my real code work, I will oftentimes write a little PySpark script just to manipulate the data, and I will abuse all the cores I have available.
Yeah.
Whereas I would find that more difficult if I would have to do that with Pandas. It's still, yeah. You could also do it like our former colleague who was a big fan of doing everything in a shell. You can do that and then you would be using like X args to use all the cores.
It's crazy.
I believe it's useful, definitely so.
Yeah. Also, the use case where we sometimes use Spark single node is if you decide to do everything in Spark and you teach your entire team in Spark, then you always will have some big data jobs, some small data jobs. That's just reality. And those small data jobs, you don't need to spin up an entire 6-node cluster to run them, right? So just run them in a single container, single node somewhere, schedule them on AWS batch or Azure batch or whatever floats your boat, right?
And if it's only for a batch job, the only cost you incur is basically like 6 to 10 seconds of warm-up time, and then basically it's all going through.
Exactly. So let's see, instead of mentioning a specific framework, I go for just a distributed data processing framework, Dataflow and Flink of valid alternatives. Lawrence. Yes, no, absolutely. Lawrence, you're right. And maybe that also relates back to the question of Spark or Dask or Flink or Beam, or they're all kind of similar. I'm going to offend a lot of people, but they're all kind of similar in that they're distributed big data processing, right? So if you know one of those frameworks, you quickly learn the other 5 or 6.
Yeah, indeed. I also feel that the more and more I'm progressing and learning about new tooling, because I don't know all of them.
No.
You start seeing that they have similar concepts that they're based on. They might be named differently, like Hadoop MapReduce was basically one of the first big data processing engines.
Don't learn MapReduce.
Don't learn it nowadays. It would be non-productive for you.
Yeah.
But those concepts, you have them the same way. In the course that I'm explaining, I'm trying to explain MapReduce with just a bunch of playing cards. And if you can do it like that and you see the exact same system coming back in Spark or in Dask, and you feel like, okay, yes, I understand, and I can optimize the programs I'm writing just because I have this mental picture of how it works.
Yeah, because behind the scenes, a map and a reduce step is very common in distributed data processing, right? So even though you don't write the words map and reduce anymore, it helps if you think about them. Okay. All right. One caveat is that Docker containers or CPU architecture dependent. Yes, can be annoying to move towards ARM. Yes. No, you're right. And maybe I'll add to that I recently learned that I was super shocked. So I don't know if you know, this has nothing to do with data engineering, but the processor in the new iPhones, I don't know how they call them, the A14, whatever, they are ARM based. And they're not just faster than a Samsung processor or whatever, they're faster than like the best desktop processors. They're faster than the Core i7, whatnot. But it's insane, they run on 5 watts versus 125 watt, and they're faster and better. So I think ARM architectures in general you will see more adoption because it's just cheaper to run. You can run faster. We don't see it a lot yet, but I can imagine like 2 or 3 years down the line that we will use ARM architectures a lot more. And then indeed, if you run on an Intel system, there is a difference in your Docker container. So that is true. Yeah. ML engineers should learn Terraform also. Yeah, Thomas, preaching to the choir, but the reality is that we're glad if we can get them out of their Jupyter notebooks. But that's just a fact.
Indeed. If you have a data scientist who goes out of the notebooks already, then
you're better than most.
Yeah, indeed. Yeah. I would like to work with those people because they are usually more aware of, for example, the business domain as well, but also how to collaborate with data engineers and the platform engineers. Yeah. So it's a really good unicorn to have in your team.
Yeah, also, lately you see this trend. I know Andrew NG recently published another post on that that said, what was it called again? Like, not data-driven AI, I forgot again, but data-centric AI. Instead of model-centric AI, like, hey, your next model optimization won't make such a difference in business performance, but focusing more of your attention on having high-quality data being available, multiple data sources, will have a much bigger impact on your AI business results. And this also comes back to this, like a data scientist optimizing models in a notebook and only doing that is becoming less and less important, I think. It's still important, but he should broaden their skill a bit to more the data aspects as well. Let's see, Dask is also great for scheduling for GPU, so not sure what PySpark support is for that. I don't think PySpark has support for GPU, right? I might be mistaken, but I don't think so.
It doesn't ring a bell.
No, yeah, good point. Yeah, thanks for sharing. We're also going to switch to the other questions that you have. I'm not sharing my screen anymore, right? But there's only one question posted on Menti is what's your opinion on Dask versus Spark? So yeah, we already discussed that. If there are no other questions, I'm going to share my screen again because I do have one final question for you guys. Share screen, it's coming, boom. You've reached the end of the presentation. Okay, no, so I thought I had another question prepared, but I missed it on the slide deck. So I think if there are no further questions, let's double check if there was something in the chat. No, I think it's good. Hide, stop sharing. Then with that, let's conclude the session, right? I hope this was productive. I hope this helped you if you're relatively new to data engineering to have a bit of a view of the 6 skills you need. I will post this video on YouTube for you to rewatch if you want. If you want to get hands-on experience with the skills we just mentioned, go to dataminded.academy and enroll in our summer school where we will teach you very hands-on how to do all these things.
Yeah, I really think that's the kicker for us, I mean, it's not just one of these courses where they just show you what you need to do. No, you will be doing hands-on work with us so that you really get it in your fingers and that you start seeing. I mean, many of our examples are well chosen. It's not just a trivial example.
Yeah.
You will need to think.
Yeah. All right. So with that, thanks all for your time, and see you next time. Bye, everyone.
Bye.
Bye.